1 RAM is more than 4 to 10 gigabytes.
Yeah. That's too much, too many bytes, too much of data. Right. Any other thoughts?
Batch processing.
Batch processing. Can you be more elaborate on that?
Doing analytics.
Your data or just one data set you constantly work on? Okay.
Unstructured and potentially ill-defined data formats or consisting of multiple different tables or databases or target engine or equivalent like SQL or something. It could be random mismatch of storage.
So it's more like a variety of data. We'll be dealing with variety of data. You said we'll be dealing with huge volume of data, variety of data. And then any other thoughts on that?
Very large platform. Gigabytes.
Right. So two big data with different volumes. Right. Okay. So I think they broadly categorize big data into these three sets. Too many bytes, which is the volume of data we're talking here. And then how frequently the data is coming in, velocity of data. And then variety of data from multiple sources comes in. So broadly, we talk about big data, they talk in this three V's here: volume, velocity, and variety. So we'll go in detail on that. And then it can be applied to any industry, right? It can apply to, like here, I'm just giving a small subset here: retail industry, entertainment, government, health or social, finance, any industries, right? If you're working in some industries, you want to share some idea, like are you guys doing any big data stuff in your company, or you know people who are doing some kind of cool stuff? You want to share something here?
Smart grid and energy. Drawing up tons of data.
Okay.
We did
some
some
smart metering here, rollouts and everything. Okay.
We did some for the Google Cloud Developer Challenge with the clean water maps. We downloaded all the EPA's water data for all of Florida and played with it. And
so can you categorize that as a big data? Does that fit in this three definition? Like, is it doesn't have a
yeah, it was a lot of data points from many different tests over the entire state from like 1995 to 2014. So it was quite a few gigabytes of data.
Mm.
And a lot of it was dirty, which is a key factor of most big data. It's got a lot of dirty stuff in it.
Maybe a little bit different report science, like hyperspectral data, it's just having hundreds of color bands or whatever, and satellite imagery, the coverage, tens of hundreds of kilometers, you know, uh, tens of thousands by tens of thousands of pixels, and aggregating multiple image sets together.
Mm. Yeah. So how many of people know about Marimeter? He puts out this report called Internet Trends every year. It's a very famous report. It covers broadly about what are the trends happening that year, how the market is heading, how the industry is heading. So now she's part of a kleiner team for venture funds, venture companies. So she recently, I think last week, she gave a presentation at the report conference. So I just took some of the slides from that. Uh, from her slide. Before I go into the topic, I just want to show you some of the trends, and then you can really appreciate why there's so many technologies converging, and then trying to provide this great platform called big data. You can really appreciate all the different technology, all the innovation going in the industry now. And that's what she said. This is her trend, saying that for this year, we think if people are enabled with mobile devices and sensors, uploading lots and lots of data, shareable data. And then more data, more transparency. There is a trade-off here. With more transparency, instant sharing, communication of many things has potential to make the world better and safer place, but potential impact with personal privacy will remain ongoing challenge. The patterns, the mining rising volume of data is put into these patterns that help solve basic unsolvable problems, but create new challenges for individual rights. And some of the times where it can be used. I mean, sensors. I mean, we'll be getting more sensors moving on. Like the iPhone, the iPhone 5, I think it has 3 sensors. Samsung has more like 6 or 7 sensors built in the phone. And then the cloud, the cost in the cloud is dramatically coming down. So people will be developing more applications, different data sets on the cloud. And then a lot of great user interface is happening here. Um, there's a lot of innovation happening in the UI area, user experience and everything. And then this is a really good one. Data mining, analytics, food equivalent, and helping finding patterns. Especially like if you say like there's so much innovation happening in the DNA industry, genetics modeling and everything. They're dealing with tons of data, but still with this technology, with all this technology now, they can do all this advanced analytics, advanced search based on huge data, huge, huge data sets now. This is interesting. This is I think every year we see more than 50% of video content are getting doubled, every year. Right now, here we have like zettabytes here. So this is from the IDC that every year the video content are getting doubled. So many people are uploading videos and everything, all the shareable data.
What's his name?
It's like 1,000 terabyte is zettabyte, I think.
How many?
I think Google it.
I'll find out.
1,000 petabytes.
What's a petabyte? It's just a lot.
It's a real lot of data, yeah. And then they expect the same trend will continue till for next few more years. Like I said, the sensors, all the phones are coming with more sensors. So with iPhone, in iPhone we have 3 sensors, there are now 5 sensors, and the latest iPhone 6, maybe there are more sensors. I think Apple recently rolled out all the health applications and the home automation applications. So you can really expect more sensors built into the latest iPhones. Same with Samsung phones, there will be more sensors. So this is also interesting. You can see like the number of sensors are going. I mean, right. So these are the number of devices right now. They have like close to uh, 8 billion devices now, with all these different categories. So this is the trend where
For some reason. Good thing I kicked it.
So this course basically it's a 1 month course. These are the main topics they covered here. They talked about two case studies which MIT CSA lab is working on, and then they mentioned about the how to integrate all these multiple data sources. What are the technologies available there, and then the storage and compute platform, the cloud computing, and then the data storage like the MongoDB, all the different NoSQL, all the different technologies. They just gave like an overall insight how it's been used, and some of the Michael Stoneberger is one of the leader of the database systems. He's been there for a long time, and he has a very strong opinion when it comes to NoSQL and SQL. So be careful. He's very opinionated. And then even Sam Madden mentioned him previously. He's the UI user interface guru there. So the case study, they did two case studies. One case study they did in the city of Singapore, where close to they want to improve the city traffic pattern. So what they did is they worked with the Singapore government, and then they went and installed all the GPS sensors in all 16,000 cabs in Singapore, so that they can find a common pattern. They can see where the traffic is peak, and then how can we can optimize the traffic in the city. So they used, I think, they're just giving you here, so roughly 5 million people, and then they were able to solve all these problems here. They can get visualized traffic and then avoid the congestion, do more urban planning, and then they can come up with all these different hotspots and congestion, whether all this is based on the data they were able to get from all these cab drivers, around 16,000 cab drivers. They're able to plan the city better. So the same thing here. And then this is one other good. I mean, I cannot play it on YouTube here, but if you have a chance, you can. I included a link here. They're working on this project called MapD. Basically, they can see if you type a word, they can see how many people are using that word. I mean, they have a sample set of close to 100 million tweets. They loaded the database with 500 million tweets, and then based on that, you can see a lot of common patterns. You can I mean, if you get a chance, I would recommend you play with that website. It's open for everybody. It provides a great insight how huge volume of data is used. I had the website here. There you go. That's the website address here. They do have a YouTube video. If you just type MapD MIT, you can see it's 2 minutes video where they talk in great detail how they implemented this huge data set application. So they talk about the traditional approach and why those traditional technologies are not applicable for big data. What are the challenges we have? Something they talk about global schemas, and then we go in detail. They mentioned about when one thing one thing they were mentioning about the structured data, like the social media applications, they do not have a structured data. So the traditional vendor, they call it big elephants. Why? The traditional RDBMS vendors, they cannot manage that huge volume data set, those unstructured data. So some other technology has to evolve. So that's where technology like NoSQL, which were able to manage those kind of huge data set. Come back to this later. So when you see this, you will get a headache. This is I think his name was Matt Asselt. He's trying to put a drawing. He's trying to put like a Venn diagram